we're essentially going to do is go through the absolute high yield information that you need to know. This is a really large section in terms of assumed knowledge because it's essentially GCSE and some A-level science and maths. Firstly, which of the following statements is/are correct about inheritance? So firstly, a single gene cross between an individual that is homozygous dominant for a particular disease with an individual that is homozygous recessive for a particular disease will have a 50% probability to have a child that is heterozygous for the disease. So the first thing you're going to do is draw out the Punnett square. They do like their balancing equation questions, so it's definitely worth getting some practice in. So you can either pause and have a go yourself, or let's go through this. So this question is saying to balance the following equation. So the first thing you're going to do to make it easier for yourself is take a look at it and see if there's anything that occurs only once on both sides. Because if you were to do, for example, oxygen, that's going to be really difficult to keep track of because you have, well, it features actually in two places on both sides. So what we're going to do is we're going to take potassium. So we're going to balance that. And so we can see we have 1 on the left-hand side and we have 2 on the right-hand side. So we'll just put a 2 in front of potassium nitrate there. And now we get to the new formula, which you can see on the bottom there, giving yourself about a minute to do it. Otherwise, let's go through it. So barium atomic number 56 is used in some medical screening procedures, such as the barium swallow for visualizing the GI tract. A chemist analyzed a sample of barium using mass spec. The results are shown in the table below. What is the relative atomic mass of the barium sample? So looking at the table, we know that we have a certain proportion of 135 and a certain proportion of 140. And so what we need to do is work out what the overall mass is. And then, so normal things like current, voltage, resistance, all of these sorts of charge as well is probably important, these sorts of key definitions. So let's go through them. So A, the energy that a single electron carries within a circuit with a unit of coulombs. So this is the definition of charge. So electrons around a circuit carry charge, and again, this is using both what it is and the units. So just to reinforce that point that I was making. Knowing the basics of Surds is generally enough, but they will try and complicate things by incorporating them into things like graphs and area and perimeter shapes and just making it a little bit more tricky for you because, you know, that's what they love to do. So let's go through some questions on them. So the first one is a relatively straightforward one, just understanding that the fundamentals of how to do basic Surd operations. So your addition, subtraction, multiplication, and division. So feel free to have a go yourself. Otherwise, let's take a look. So express the following in the form of a root 5, where a is an integer. So we have 4 root 15 times root 3. So we know we need to get to root 5, and therefore we need to get rid of that root 3 at some point. So we're going to have to multiply that. Step 2 is ionizing ability. So alpha radiation has 2 protons and 2 neutrons, which is the same as the nucleus of a helium atom. And because of the large size and the high positive charge, because it has 2 protons, it's able to pull electrons away from atoms when it collides with them. And therefore, if you take an electron away from an atom, it's now going to have one sort of less negative charge on it. So it will probably have a net positive charge and therefore will now be ionized. And so ionizing it makes it highly reactive, and therefore it can react with all sorts of structures, including the negative phosphate groups, which you find in DNA.